Hello, thanks for joining us today. We're going to be talking about Power BI's incremental refresh and hybrid tables and how you can use these features to improve the refresh times and latency of your reports. My name is Chris Mitchell. I'm a principal cloud solution architect, and I'm part of Microsoft Global Partner Solutions team. Just a reminder that this and other sessions can be found out at aka.ms/MAA. So let's dive in. So what we're going to do is we're going to spend a little bit of time evaluating the various storage modes that Power BI offers and look at the pros and cons of each of those. And then we'll dig into the various features that we want to discuss today. First, we'll look at incremental refresh, and then we'll also look at hybrid tables and how the hybrid tables kind of is an extension of incremental refresh. And then finally, we'll dig in a demo and give you guys some guidance that you can use to take forward and apply this in your own implementations of Power BI. So first of all, it's important to look at the fact that Power BI's got a variety of different ways that it can access data. The storage mode that's been around the longest is called cache mode. And in this particular mode, what Power BI does is it prefetches all the data, compresses it using the Microsoft Vertipack engine that you can find in other products as well, like SQL Server and Synapse. And then this keeps the data really small, but it's all held in memory. And the purpose of this is to give Power BI the fastest performance possible when rendering your reports. Now, this works really great for a lot of scenarios, but there's some times when there are limitations with that cached mode that we're required to switch to a direct mode. Now, direct query mode, instead of pulling all that data in cached, all it really does is hold on to metadata and interactively queries the underlying data source. So naturally, because it's got to write and send queries to that underlying data source, it's not going to work with all data sources. The reason for that is the Power BI engine needs to do things like potentially create joins between tables or do group bys, where clauses, and aggregation functions in order to fulfill the interactive fulfill the activity that the end user is issuing against that report. And so it really is only going to work with a specific set of relational databases. It's not going to work against things like data lakes with CSV files or Parquet files underneath the covers. And then finally, dual mode is what it sounds like. It's a little bit of both, and it solves a pretty specialized scenario where Power BI might be using a combination of direct query and cached mode, and it lets the engine selectively decide whether it's going to go direct mode to fulfill the query or it's going to go off of the cached set of the query results based on what the user is doing at that time. So digging into these individual storage modes. So cached mode, we already talked about a little bit, but it's important to call out that cached mode is how you're going to get your fastest report performance. The reports are fast because data is in memory. And the reason we can get away with that is because we're doing this compression engine and we're taking large volumes of potentially relational data or CSV data or whatever and compressing it so that it holds up in memory really well. The nice things about this, as we're calling out here, your DBAs will like you because you only really touch that database when you're pulling the data. You don't ever touch it for interactive activity. And the other thing is this is like a great neutralizer. It can pull data from all different sources. I call Power BI a data omnivore, right? It can eat data from any location you provide it, and it doesn't really care what the format of that data is or the data source, because it can connect to all sorts of things like your third-party CRM system, a RESTful API, a file share, or even a relational database. Now, obviously, the problem here is going to be that because it's pulling that data in a cached mode, sometimes that means that latency could be a problem, right? If your end users are having challenges with, they need to see the report very near to when the data arrives in the source system in the reports, cache mode can be a problem because it refreshes those on a schedule. Also, as your data volume grows, the time that it takes to refresh your model can get more and more expensive. And as you'll see, the things that we're going to be looking at today with incremental refresh and hybrid tables are really designed to address these two problems, data latency and data volume growth. So with direct query mode, as we called out, none of the data gets pulled into your report. It is all queried interactively. The value of this is that now when you run a report, at the time you run the report, it's going to be issuing a query against the underlying database, and it's going to be the latest and greatest up-to-date data. But this comes with a cost, right? The cost is that Power BI, if you have heavy usage or you're sending really expensive queries to that underlying database, it can cause performance issues on that underlying database. You know, your DBAs could be coming at you with with pitchforks trying to figure out why you're impacting performance for your organization. Um, and as I said, it only works with some data sources. So you know what? If your data is in a file share somewhere, you're going to have to use relational. You're going to have to use the cache mode, or you're going to have to intermediately move that data into a relational database. And then finally, you know, the design of your underlying database, the size of your underlying database, all those things can impact how well direct query mode works. And then obviously, as the data volume gets bigger and bigger, Power BI may be issuing queries that need more and more and more data, and therefore the queries will take longer, and as a result, your end users could have poor performance. Now, composite models is actually kind of a special case. It's really designed to strike this balance, like I said, between cached and direct query, right? We want to get the benefits of cached, but there are certain objects that we're having to work with, certain tables or entities that may be exceptionally large or may not have that direct query benefit, right? So you could have a model where I've got a relational database that has got a very large table in it, but then I also have side-loaded some data out of a CSV file that gives me some special grouping criteria or something like that. So the idea here is I can mix and match based on the intelligence of my source system and then also the requirements of data volume. So the thing to keep in mind here, though, is that while this sounds like a panacea, right, I can mix, you know, intelligent and non-intelligent data sources together and create them in a single model. The thing that you need to be aware of is that the queries can get really expensive and really complicated to these direct mode objects. For example, if I said I have a, you know, list of thousands and thousands of thousands of products, and I said I want to give me a list of aggregated sales based on this list of products that's in cached mode, it will have to do a select query where it does a big in statement at the end and has to push all those individual keys down in that in clause in the select statement. So your query statements can get really, really, really large and complicated, and that can cause some performance issues as well. So that's an important thing to think about. All right, so now that we've looked at these different storage modes and the fact that you can kind of mix and match them in a Power BI model, let's look at what incremental refresh is and how it's designed to solve some of these problems. So when you define incremental refresh, effectively what you're doing is you're setting a policy that tells Power BI where to expect the data changes in your data set, and it also tells it how much of the data set that you care about. So for example, if you had a fact table that had, you know, 10 years worth of data in it, but you were only committed to have 3 years worth of data in your reporting, you could say, hey, give me data for the last 3 years. And then, by the way, I expect data changes in the last 7 days. And so by doing this, now when your Power BI model refreshes, it's only going to, at any given time, refresh the last 7 days, and it's going to dynamically shift that date as you move forward in time. And it's going to do a really intelligent job about how it does this, so it doesn't have to every single time you know, you switch to a new month, it's not going to necessarily have to reload old months of data. It's got a pretty clever way that it addresses that so that it can minimize the amount of queries that it sends to your underlying database and optimizes your refresh time. And so, like I said, this is a policy-based thing, not a hard-coded rules-based thing. So what you don't have to do is go into your model and manually create these partitions. You define the policy that says, I need the last 7 days refreshed, and then I can archive the last 3 years, and the Power BI engine takes over when you deploy the model and turn on schedule refresh. And as I called out, the big advantage of this is that we're reducing the amount of data that we need to pull from your underlying database. That means your refreshes are faster. That means less load on the source database. Your DBAs are happy, and the refreshes are faster. So if you're in a situation where, let's say, you're doing multiple refreshes a day, right? You might be doing, you know, one every half hour or something like that. You're less likely to be in a situation where your refresh cycle time, meaning how long it takes your refresh to complete, can make sure that that refresh completion happens before the next refresh window starts. And so with that background in incremental refresh, let's look and see how hybrid tables are a little bit different. So effectively what hybrid tables is doing is bringing together the concept of composite models where you can say one object is direct query and another object is cached mode, but it's taking that down to the partition level. So remember I said that when you turn on incremental refresh, it breaks your table into a series of partitions based on date ranges. Now, what it can do is the hybrid table can effectively make one of those partitions in that table direct query. And so what this enables us to do is it enables us to still use incremental refresh to govern the recent day's worth of data, but all the data for today, let's say, is real time. And that means that if you have a data that's changing fairly frequently throughout the day, or you need to minimize the latency between when the data arrives and when it's visible to your reporting system, this is going to give you that. So it's like the best of both worlds. It gives you the fast responsiveness and low latency of direct query. It gives you the reduced query overhead and refresh time of incremental refresh, but then it also gives you the benefit of cached mode from a performance standpoint. So it's this idea is it's trying to find that perfect sweet spot, the intersection of the Venn diagram, if you will, where we get, fast report performance, low overhead from a refresh time, and then very, very low latency, kind of all mixed together. All right, so I've talked a lot and I've used a lot of words here. I'm going to take a pause for a second and I'm going to dig into Power BI and I'm going to show you how to configure these and what some of the differences are when you configure them. All right, so let's jump into the demo. So here I have a Power BI report, and this report is built off of the basic AdventureWorks data model. And in this data model, I've just got some customer information, some product information, and some sales information. And our big table here is going to be the fact internet sales table. This entire model is currently in cached mode. What I'm going to do is I'm going to set up incremental refresh and then hybrid tables on this model. So in order to do that, I need to go into the transform data area here. This is going to take me into the Power Query editor. And inside here, what I'm going to need to do is define a couple parameters that PowerBI.com will use when it manipulates the refresh schedule to assign partition boundary ranges. So first thing I'm going to do is create a new parameter called range start, and its date time is the data type, and it's going to be January 1st, 2022. I'm going to create a second new parameter called range end, and this is also going to be of type date time, and I'm going to set it up for January 1st, 2023. Now these parameters are just for design purposes. They're going to get applied later on. So you can pick any date ranges you want, but it's also prudent to choose some date ranges that are somewhat restrictive to your data set. If you're dealing with a fairly large data set, you don't want to spend a lot of time pulling in a whole bunch of data when you're just doing the report design and modeling. So now that I've got those parameters defined, I'm going to go to fact internet sales, and I'm going to look for one of my columns that I have here called order date. And I'm going to define a custom filter on that column to do it. This custom filter is going to be after or equal to the start of the range and before the end of the range. So I do after or equal at the start, but only before at the end, so that I make sure that when I have multiple adjacent partitions that they don't overlap. Click OK, I click close and apply, and this is now going to update my data model to include those parameters, and it's going to be now filtered down to just that year of 2022. It's doing a little bit of a load process here because it'll reload the data after I change that data model. And then the next thing that I want to do after this is start applying that incremental refresh policy. So far we've just put some scaffolding in place that the incremental refresh policy can work with. Now what we're going to do, and I'm going to do this two different ways. I'm going to show you how to set up incremental refresh, and I'm going to show you how to set up hybrid tables. And then we're going to go over to Power BI and look and see how it looks under the covers once the models have been deployed. So if I click here and select incremental refresh, I can say incremental refresh this table, and I can set up a policy that says, hey, my older data, my archive data, starts 3 years before the refresh date. So 3 years, or choose what option is relevant for you. And then I'm going to say that my changing data is in the last 7 days. So what this means is that when we initially publish the model, It's going to load that 3 years of history data, and then it's going to load a series of partitions for the last 7 days. And then as we move forward in time, it's only going to update the last 7 days. Now, if I click apply here and I save and publish this model to powerbi.com, this is going to be set up for incremental refresh. Now, if I want to go in and set it up for hybrid tables, the only thing that I have to do different here, and I should have called out here, you can see it gives you a nice little graphic that tells you what's going on here, right? The only thing I have to do to turn on hybrid tables now is turn on get the latest data in real time with direct query. And so what that means is the last 7 days will incrementally refresh, but the most current day is going to be running in direct query mode. And I click apply that, same thing, publish or save, publish that model. You'll have a slightly different behavior, but we'll see what that looks like. All right, so now that I've got that, fast forward in time, I've actually saved both of those models and published them. If I go out to powerbi.com, you can see here, I could look at my workspace settings. You can see here in my workspace settings, I've got an premium feature here, the workspace connection. This is important because we're going to use a tool called Tabular Editor to examine what's going on underneath the covers in the Power BI model. So just take a copy of that, and we'll go over to our Tabular Editor tool, and you can see I've got the model open, but I'm going to open have the hybrid table open, but we're going to switch over to the incremental refresh model here. And I've got this incremental refresh model. And when I expand the tables section, you can see I have my fact internet sales table, and I've got a partitions area. And you can see we've got a lot of partitions here. So what's going on? So obviously the first 3 years, 2019, 2020, and 2021 are our last 3 years of archive data. And then we would expect that, and then we'd also expect the last 7 days to be of incremental data. So you can see I've got a lot more than the last 7 days here. So what's going on? So in order to save Power BI from having to create a partition that is everything up till the last 7 days, and then a partition for each of the last 7 days, what it does here is it's got a partition for the first 2 quarters of this year, and then it's got a partition for every single day since then. What's going to end up happening is tomorrow there will be a partition for the 5th of August and the 6th of August and so on, etc. Until we get to 7 days past the end of Q3, then all of this data will get collapsed down into a Q3 partition, and we'll have 7 days for Q4, and so on and so on. And so what we'll do is we'll keep building up all the days in the quarter as individual partitions until the quarter is complete, and then we'll collapse all them down into a single partition. So the number of partitions you're going to have is going to be dynamic from day to day based on how Power BI is managing that policy. But the important thing here is what it's trying to do is minimize the number of times it has to refresh large volumes of data rows. Right, and if we looked in each one of these individual partitions, you could see for the 2019 partition, you could see it's got a granularity of a year. It's in import mode, and it is from the 1st of January 2019 at the start till the 1st of January 2020 at the end. And same thing with 2020. It starts at the 1st of 2020 through 2021. You can see the quarterly partitions. They look a little bit different. They've got a granularity. A quarterly granularity, and they've got the start from 1st of January to the 1st of April. And then if you go down in the individual day partitions, you'll see, again, import mode, day granularity, start of the 1st of July to the 2nd of July, all the way up until our current date, which is also an import mode, day granularity from the 4th of August to the 5th of August. So let's take a look at how this might look a little bit different in the hybrid table mode. I think you might already have an idea, but we'll just look anyway. So in the hybrid table model, if I expand the tables again, go down to fact internet sales, you can see I've got all the same partitions. They look the same, but the one that looks different is this last one. So what does this mean? 08, 04 onward. So what's going on is it's still got a granularity of day, but it's in direct query mode, and it's also got a start date of today with an end date of some date arbitrarily far in the future. So what is this enabling? This is enabling us to have this open-ended partition at the end. So as we insert data, depending upon where we schedule our, how we set our refresh schedule, we could set it for, refreshing once a day, once a week, whatever. What'll end up happening is we'll make sure that we don't miss rows as they get inserted. And so this is really important because, if we didn't do it this way, that incremental refresh schedule with the hybrid tables, we could end up losing some data. And so this helps us make sure that we don't lose those rows. And it lets the direct query that happens against that partition, dynamically deal with that just by saying, hey, where date is greater than and less than this January 2028 data. All right, so let's flip over and look at these reports now. I'm going to go pop over to my workspace. And you can see here I've got a number of Power BI models deployed. The first one that we want to look at is incremental refresh. And you can see this is set up with a refresh schedule. It refreshed recently. Its next refresh is at midnight tomorrow. Same thing with our hybrid table. What's different though is if I go into my Power BI report here, I'm going to look at this order volume by day. And so you can see this order volume by day is 178 orders for August 4th, which is today. If I look at that same report in my hybrid table, you can see my volume is actually a little bit higher. And the reason for this is I inserted some rows into that table after I refreshed the model, and that's why they haven't been caught by the incremental refresh one, because they won't catch those rows until tomorrow. But this one, since it's running on direct query, it's going to catch them. And I'm just to prove that there's nothing going amiss here, I'm going to go out here. I have a query that actually goes out to this database and the fact internet sales table and inserts a row. And so I'm just going to run this a bunch of times just to see. 2, 3, 4. I think I clicked it about 4 times. Let's go back over to Power BI. If I click refresh here, you can see this number is now updated. Yeah, I clicked it 4 times. Now it's updated to 195. And so you can see what's happening behind the scenes is it's actually doing a live query against the database in order to fulfill this one slice of data, and everything else is coming cached off the data model. Okay, so now that we're done with the demo, I wanted to jump in and review just a couple things about best practices guidance for how to leverage these principles when you're implementing in their own environments, and then share some helpful resources with you. So first of all, when you're embarking on one of these journeys where you're wanting to potentially leverage incremental refresh or hybrid tables, I think I'd be remiss if I didn't call out the fact that a lot of times there may be other problems that exist that you should probably address in advance of implementing incremental refresh or hybrid tables. For example, a lot of times incremental refresh gets turned on specifically to address the speed of data refresh. And while it does a great job of addressing those issues, there could be other things that are coming from your underlying database. It could be the number of table joins you're doing. It could be a lack of indexes, anything like that that might actually be causing that refresh performance issue. And so just turning on incremental refresh may not help as much as you think. And so what I would recommend doing first is starting off with examining the queries that Power BI is issuing to your underlying database at refresh time to make sure that those queries are running well, because you could be potentially fix some issues that you have before you even need to think about implementing incremental refresh. So assuming that everything's running well there, you've got good queries behind the scenes for your refresh, then that's when you would want to dive into incremental refresh or hybrid tables. So when I look at incremental refresh and hybrid tables, this is the decision guide that I use kind of in my mind to think about, like, what's the right implementation here? And this is just a good guideline. It's not, hard and fast rule. It's just a good guideline to what the appropriate both storage mode and refresh methodology is going to work for any given situation. And so I'm not going to go through everything here, but I just want to call out on the left-hand side, we're talking about as your data volume grows, when are you moving from cached towards incremental refresh? And as your latency requirements grow, when are you moving from cache towards direct query or incremental refresh or hybrid tables. So just general principles here. So obviously you can see as we both go up in data size and data latency requirements, hybrid tables becomes essential. But there are many scenarios when you have, fairly tolerant latency windows that you can get away without implementing hybrid tables, and incremental refresh or cache mode might be just fine. All right, and resources. One of the things that I demonstrated earlier was how to look at the underlying partition structure with Tabular Editor. Just to call out, Tabular Editor is a solution that's out there. There's a paid version and a free version. The paid-in version has some advanced features, but everything I demonstrated to you today was with the free version, so you're free to download that and use that to explore the underlying structure of your Power BI models. There's also some other resources out here that point out the documentation on some of the features that I demonstrated today, like composite models, documentation on storage modes, incremental refresh, and hybrid tables, and then also some other guidance about how to monitor and optimize your Power BI models. So I thought all these resources might be useful. And with that, that's about everything I wanted to cover today. One more thing I wanted to call out before we close out for the day is this and other sessions can be found at aka.ms/MAA. And I'll also mention that when we publish this vignette out to MAA, we're going to also have a set of companion code that goes along with it. So all of the scripts that I used to create my sample databases today and some Power BI templates that already have the model pre-built and parameters predefined in them are out there for you. And we'll also have some README guides out there for how to set up this in your own environment, just so you can experiment with it and play with it on your own. So hopefully you found this useful, and we appreciate you joining us today. Again, go out to aka.ms/MAA to find this and other sessions. Thanks.